Hello and welcome to Big Ideas Only. Today we're talking about computer visuals or vision, that is. So, how does a computer actually see? And this is a branch of AI, and I find it really interesting, but also somehow concerning because it involves filming a lot of stuff all the time. And to kind of enlighten us on this topic, I've invited Andreas Møgelmose, who is the Associate Professor of AI at Aalborg University. And in that department that's called, or it's not a department, it's a lab, so to say, but it's a lab called Visual Analysis and Perception. Andreas, are you with me?
Yes, I am.
Perfect, perfect. I think a good place to start would be, very briefly, what is computer vision and why is it a big idea?
So, computer vision is about making computers see, basically. So, taking a camera, plugging it into a computer, and making the computer understand what it's looking at. Why is that a big idea? Well, I would argue that our sense of vision is probably our most important sense. So, a lot of the stuff that we are able to do, we're only able to do because we can see. And that means that if we can have a computer be able to see, then we can make the computer do stuff that would otherwise not be possible.
I actually wrote down, it's a question that I've jotted down, like, way down this interview, but let's just bring it up now. You say that the vision is the most important of the senses. Is it enough, or do we need the other senses as well?
That depends on what you want to do. So in some scenarios, vision is sufficient.
Mhm.
If we want to do face recognition, like when you're on Facebook, I don't even know if they do it anymore, but it used to be that you could tag your friends, and then at some point it would tag your friends automatically. That is something you can do with vision only. So for that task, vision is clearly sufficient. We can take another case, which is self-driving cars that I've done a lot of work in, and in self-driving cars, it's still an open question whether vision, as in visual RGB cameras, is still enough. Elon Musk believes that it is enough. He believes that Teslas can drive themselves based on camera input only. The rest of the world disagree and think that we also need stuff like lidars and other types of sensors, which you can argue is part of computer vision as well, but it's not like a visual camera. It's another sense of vision, so to speak.
Yeah, so we're not necessarily talking about the typical senses that humans have: smell, hearing, touch,
Not
those.
necessarily. The advantage of electronics is that we can build all sorts of sensors that can perceive things that we humans would not be able to see, like thermal cameras, which is also a sub branch of computer vision, or radars, or whatever you can imagine. So there are many different types of sensors that exist that go beyond what humans can do.
Mm. And let's just try and dive down into some of the use cases. So you mentioned self-driving cars. That's a pretty obvious one, I think, because you see the Teslas driving around with all the cameras on them. What other use cases would there be for computer vision?
We see computer vision in many, especially industrial contexts. So that's not what is talked about all that much. People tend to think about face recognition and access control and surveillance and that kind of stuff. But really, I would argue the most common use case for computer vision is in industrial production. So if you want to be able to have a robot pack a pallet for you, well, maybe you can pre-program the robot, but if the stuff it's packing on the pallet is not completely uniform, it needs to understand on the pallet and what it's currently lifting to be able to pack that pallet correctly. If you want to have a robot weld something, you might involve cameras. If you want to have a robot paint something, you might involve cameras. So there are many industrial contexts where you can use this. Also in healthcare, recently in my region of Denmark, the northern region, the hospitals implemented what they call AI checks of X-rays. So if you go in with a potentially broken arm, it used to be the case that a so you would go get an X-ray, and then you would have to wait for a radiologist to come look at that X-ray to tell you whether it's broken or not, and to tell the nurses whether they can put on a cast or not. And that was a huge time sink because there aren't many radiologists. So now they've implemented a computer vision system which can take a look at these X-rays and can tell whether it's a broken bone or not. And if it determines that it's a broken bone, then the nurses can put on the cast straight away. And that has meant that people wait on average 1 hour hour less in the emergency room in our
And
emergency
and
departments.
and is it accurate?
Yes, yes, it is. I don't have the exact numbers for that system, but it's certainly above 99% accurate. So it's not that it's perfect. Of course, it will make mistakes, and of course, they've taken that into account too. So many people talk about human in the loop AI systems these days.
Mhm.
Not many AI scientists, but of course they are out there, but not many AI scientists want to replace humans. What we really want to do is augment whatever the humans are doing already. So a radiologist do not think that it's particularly interesting to look at an ordinary broken arm. They have lots of more uh,
Yeah.
challenging stuff they can do, and they are very busy. So we can automate like 10% of their work. But then we also know that the automation is not perfect. So what they do is then they gather all of these pictures for what they call a morning conference. So the next morning, when a radiologist is in office, then the radiologist can go and check all of the X-rays and see whether the robot made the right decision.
Whether you should call in the patient again and then take off the cast.
Yes, so they will do that in some cases. But so with all AI, we have this trade-off that it's not perfect. Humans are not perfect either. We can get back to that, but they're not perfect, so mistakes will be made. And so in this case, the doctors have decided that this is a worthy trade-off to make that. It is so good that the vast majority of people will get the correct treatment and all is well. And in those few cases where it might be wrong, there's still time to get the patient back in, take the cast off, do something else. While that might not be the ideal outcome for that particular person, of course it's not. It overall gives a better outcome.
Mm. I think that that way of thinking about outcome and impact, whether it's good for the individual or good for the masses, that must be something that you meet quite a lot. I'm thinking also about it, it's a the classical example of self-driving cars also.
Mhm.
Who do you want to kill, the driver or the
Yes,
old lady crossing a red light?
yes. And that is an extremely contrived example because
Yeah.
that is not how self-driving cars work. It's also not how we work when we drive. I mean, first of all, I'm sure you have never been in that situation where you're driving down the road on your car and you have to consciously decide, do I kill the old lady or do I kill the dog over there? That's just not how you drive, right? You make sort of an instinctive decision in a split second, and
Yeah.
then something happens, and of course there might be really bad consequences. But we don't work like that, and that's not how AI systems work either. They perceive the world much in the same way we do, with some probabilities of seeing something, or some probabilities of something or another thing
Mm,
happening. And there simply is no element of the AI that is going to decide, is old lady more valuable than dog. It's just not part of the system. The system has sort of an overall target or a cost function, we might call it in technical terms, that it has to minimize. So it minimizes cost, but cost here is not about saving lives, or like it's much more about how can the car find a good path through this scenario that it is in. So it would probably, if it can't avoid the dog and the old lady, it's gonna block the brakes and then it's gonna stop, and hopefully before it hits anybody. But it's not going to consciously decide between the dog and the old lady.
all right. So yeah, so it's like it basically creates like a miniature Google Maps and then says, okay,
Yes,
what's the best route here?
yes. What's the best path through here? Yeah.
Yeah. Okay, okay.
And if there's
Um,
no path, it will stop. Yeah.
yeah. Coming back to some of the different use cases, because again, the self-driving cars one is fairly fairly obvious, and a lot of people talk about it and also talk about this dilemma, of course.
Mhm.
Um, what fascinates you? What are you looking most forward to coming within computer vision?
What I'm really fascinated about is software that can directly interact with the world. So being able to make a system that can see and understand the world to some extent, and then affect something out there, whether it's
Mm,
controlling a robot, controlling a self-driving car, or just helping out with decision making. That I think is super neat to
mm.
be able to do, rather than having somebody input something manually into an Excel spreadsheet. I'm really fascinated by computers that can interact directly with the world.
And is this only a matter of it being able to see something and then interpret that? Or is it also about reasoning and um, well, thinking about context and all this. How much of that are you
Uh,
looking into?
I think what you're suggesting is almost an impossible line to draw
Okay.
because to be able to see and understand something, you very often have to understand the context of what you're looking at. So I don't think you can tease them apart like that. But I mean, I am interested in the whole pipeline. I happen to be the most specialized in understanding in making the computer understand visual information and also make decisions based on that. And then what I am less experienced in, but have done some work in, is okay. Then how do we move stuff in the real world? So how do we actually move the robot arm? We have some really
Mm,
good robotics people at our university and elsewhere that are very good at making sure that the robot arm will move to a particular point in space. I
mm.
don't care so much about how it does that, but I do care about sending that information to the robot so that it will move to a particular point in space.
From your cameras, are you deducting some kind of 3D image of the surroundings and then saying that
That that
on
that
this and
might
that axis,
that can
put the
definitely
pen?
happen, but it doesn't have to. So it depends entirely on the context of what you're building.
Mm,
So if you go back to the X-ray example from the hospital, then we don't need to do all that. Then we need what's called a classification system. So we need to be able to show it an X-ray image, and then we need to have a intelligent system for some definition of intelligence that can decide: is this a broken bone, or is this not, or is this so complex that we need to operate, for example. So in that case, we would just have the classification part. Other times, if we need something to be able to navigate in the real world, if we need to control a self-driving car, if we need to control a welding robot, if we need to aim at an incoming drone to shoot it down, or whatever you can imagine,
mm.
then you need a 3D understanding of the world to be able to achieve that goal. And that is also something that we work on.
How many sensors would you have to combine to game such a 3D world?
You can do that with the visual sense. So what you can, so we have that as humans. We have two eyes. That's called stereo vision. And when you have two eyes, you see things from slightly different angles,
Mm,
and that actually means that you can judge the distance. Now our eyes are actually not very good at that because we have a very short baseline, it's called. So we have a narrow distance between our eyes, and that means we can actually only use this out to maybe 3 meters. Don't quote me on the exact range, but it's something along those lines. That makes sense because very few of us have arms longer than 3 meters, so we really only need very precise distance determination.
Extreme ape index.
Exactly, exactly. So we only need it for stuff that's within reach. Now we also need to be able to judge distance at longer distances, but then we use like a different part of our brain where we know how big stuff is, and then we look at that, and then we use sort of our experience to see, well, if that's a car I'm seeing there, then it's probably out at 100 meters distance, and that's something we can practice. But that's separate from our binocular sight. Uh,
I someone told me that one of the electrical cars that's out now, which one is it? I think it's the maybe the Xpeng or some one of those. It has the front light is just like one singular line.
mhm,
You've seen on many cars,
Yep.
especially for the backlight,
Yep.
but it's just one singular line with like uniform line.
Yes.
And people complain that it's hard to see how far it is away
Yes.
because
Exactly.
you would have two headlights,
Yep.
like and they would then be very narrowly together, and the closer the car comes, the further apart these two dots of light would be. That
Absolutely, and,
yeah.
and that so we know this from many scenarios in our life, that we use our experience, our understanding of the world, to perceive the world, and that's
Mm,
what we then try to put into a computer. So we can actually build stereo camera systems where we take two different cameras, place them spaced a little bit apart, and then we can from that we can calculate a
mm,
3D understanding of the world. Then sometimes that doesn't work, and then we have other, like we can use radars or lidars, like which is laser scanners.
mm,
We can use time of flight cameras. There's a lot of different technologies for building a 3D understanding of the world, but we can definitely do it with vision only in many cases.
mm. Now, I want to come back again to so we've got the cars, we've got healthcare, we've got a little bit of robotics. Um, I'm one of the robotic things that I don't understand is in Denmark we sort our trash. into different
Yes.
fragments. And I don't understand why we have to do that. I don't understand why you just why don't you just buy a big robot that just
Yeah.
sorts it for you based on, well, yeah, computer vision, X-ray
Yeah.
scans of materials or whatever, those kind of things. I just don't get it.
No. And I think it's gonna come. So I mean, in the municipality where I live, we actually have a system for that, and it's not super sophisticated. But basically, we have two different colors of trash bags. Then you put one type into one color, another type of trash into another color. Then you put it all in the same bin, and then when they go collect it, it ends up on a conveyor belt somewhere with a camera looking at the trash bags, so that they can scoop the green trash bags to
Just
one
yeah.
side and the black trash bags to one side. And that's sort of a simple version of what you're talking about.
Mm,
Um, the big challenge, of course, if you just wanted to be able to put everything into the same bin without any bags or anything, is that sorting trash is actually very, very difficult. You might have a plastic container that is smeared with food, for
mm.
example. Okay, can you even see that it's plastic, or do you have to pick it up and hold it? Like if you were doing this at a conveyor belt manually, I think it would be an extremely difficult task. And we also have different materials that might look very similar. So sometimes we can get by this by using either other types of sensors, or like purely mechanical means, like you could have a magnet pick up a lot of the metal, at least the ferrous ones. Um, but we are getting better and better at this. So at like in the future, I think that is gonna be automated.
Mm, mm. One thing that I think it definitely will come in the future is humanoids. So or robots that look like humans.
Mhm.
Computer vision, how does it entangle into that field?
Well, if you want a humanoid robot that can do all the stuff that humans can do, then as we talked about earlier, you really need the sense of sight.
Mm,
It wouldn't be able to navigate the world if it couldn't see the world. Then you would probably have it rely on other sensors for part of what it did, but there are just so many human-like activities that you need sight to be able to do. And aside from that, you just need it in order for the humanoid robot to function properly. I mean, it needs to be able to keep its balance. If it's going up a staircase, it needs to know the staircase, etc. So if you want any robot, whether it's humanoid or not, to really navigate a changing world, then you need vision.
the vision that a humanoid robot needs, is that already developed, or is it still?
So that's like asking whether we have self-driving cars or not. On one hand, we have self-driving cars. If you go to Phoenix today in Arizona, you can go on a self-driving taxi. You can go anywhere within the metropolitan area. It will take you there without a driver, without any human intervention. So with that set of glasses on, well, then it's solved. We have self-driving cars, just like we all promised you 10 years ago. On the other hand side, if you want to go to where I live at the end of a gravel road, way out in the countryside, in a self-driving car, there is no self-driving cars that can do that today, and probably not for the next 10 years, or maybe even further into the future. So so that would lead us to say, well, we don't have self-driving cars today. And likewise, if you
Yep.
talk about humanoids robot vision, we have excellent vision that can recognize faces, for example. So if you want your humanoid robot to recognize you or me, or somebody else, well, then we can do it today. If you want it to be able to do your dishes, then we probably cannot do that, because that would mean, and that's not only a vision problem, that would mean that the humanoid robot can grasp very complex objects that are organized in very unorganized ways, and there are just it's just super super difficult.
I'm thinking that is mainly a software problem right now.
Yeah.
Yeah, so the hardware is already there. And that also means that once the last of the software problems, the gravel road software problem, once that's solved, we basically can have well, autonomous vehicles, robots walking around amongst us. What happens with all the collected information?
That depends entirely on how you architect your system, and what requirements you have for your system. So currently we have many different levels of computer vision algorithms. We have stuff that was developed back in the 70s, which is super simple. You just take a picture, and then you in a very manual way check, are there any green pixels here? That might work well in certain scenarios. That is stuff that can run directly on the device. So in that case, you wouldn't send footage anywhere. You would just have a camera on the device that captures something. It would process it. It would make a decision. The footage is thrown out. It never goes anywhere. We also had that have that for more complex systems, not just these super simple 70s ones. We also have it for small neural networks, etc. So for many things, you would be able to do stuff on device, and the footage would never go anywhere. Of course, then the device could potentially save it, but there's no from a vision perspective, there's no need to do that. Then we have some algorithms that are not yet quite ready to stay on device. So if I want to take some of the newest computer vision transformer models that are the types of models that are best at recognizing stuff in complex scenarios, then I would have to send my footage to some server somewhere, just because there would be more compute power on that server. But maybe I don't. I mean, maybe if I have a self-driving car, not to to harp on that all the time, but it's just a really good and easy to understand example. In a self-driving car, you have a trunk. There's a lot of room in that trunk. You can put a pretty big computer in there. So even in that case, you don't necessarily send your footage off. Also because you want a self-driving car to be able to react instantly. So you don't want to incur any transmission penalties
Mhm.
time-wise. So sometimes you can just run everything on device. You don't have to save anything. Other times we have to ship it off to some server farm somewhere, and of course then the footage might be captured by people with ill intents on the way to that server or at that server. But it might also be the case that the server just receives the footage, makes a decision, deletes the footage, nothing happens.
Is there a problem? Because you say that it actually basically just deletes the data once it's used.
It
But
can be for sure, but it's more about how you implement it than the actual algorithms. Okay, we have some big algorithms right now that would require you to send your footage somewhere, but even that can be done in a safe manner where your footage doesn't go anywhere, nobody saves it. But what people often do is, of course, that they save this footage. So it's more about auditing how stuff is implemented. So if we have cases where we don't want footage to be saved, we need to have some guarantees that that is not done. So that's one aspect of it, with sort of where you can talk about illicit saving of footage. Then you have other scenarios where the actual footage leads to some decisions that impact people's lives. So I'm actually not a very big proponent of surveillance. I don't like the the whole concept, but but uh, when you do surveillance, regardless of whether you do any AI or any computer vision or anything, you usually save that footage. And then you can track people on that footage. And then, of course, if you have an AI system that's a really, really good face tracker, or something that can do what's called re-identification, where it can re-identify you, not necessarily based on your face, but based on all sorts of attributes on your body. So it doesn't have to see your face necessarily very well, but it can find you. Then, of course, AI can enable surveillance and mass surveillance on a scale that has never been before been seen. So AI can definitely enable stuff that is ethically questionable. But I'm hard pressed to say that AI in itself is ethically questionable. If you get my distinction.
yeah, but it all depends on what you're going to use that data
Yeah.
for, and if you are saving data that you should not be saving, also.
Yeah. And of
Mm.
course, I mean, you might also be saving data for fully legitimate reasons. Tell everybody that I'm doing it. Nobody's surprised about it. But then somebody gains access to this footage, and then they can do nefarious things with it
Mm.
too.
Mm. Say authorities, they may get access to different kinds of footage and face recognition software,
Mhm.
so they can see who's entering the subway, and that means that they can then pinpoint if there are any criminals amongst those people and then track them down.
Yep.
And that is already happening. It's already happening in Denmark, and
Absolutely.
it's happening all over the world.
Yeah.
Um, to me, it smells like a very slippery slope.
I agree. I fully agree. I just disagree that it's an AI problem, because cameras in the London Underground and all over London did that when I was in London as a high school student in 2004 or something like that. So this has been an issue for a long time, and is not particularly related to AI. But of course, what AI can do is that it can now enable actions on this footage that was otherwise unfeasible because people wouldn't be able to look through it all. So
Mm.
that makes a difference, of course.
Yeah, yeah. Our time is nearly up, but I want to ask you here at the end, what are you looking most forward to in terms of computer vision and the boundaries that technology in itself is pushing?
So there are lots of interesting technical challenges still to be solved. So maybe during this our talk it sounds a little bit like, oh, tomorrow we have humanoid robots that can do whatever we can do. And that's certainly not the case. We have really strong computer vision in some scenarios, but in other scenarios we don't. And oftentimes it's not obvious if you're not an expert to know what is hard and what is not.
What could
Ex-
examples be?
yeah, so we have an excellent systems to recognize birds.
Yeah,
But if you then ask, oh yeah, but which type of bird is it?
yeah.
Then we fail completely. That's something called fine grained analysis, and systems are not very good at that. It's good at recognizing broad categories. It's not good at these fine grained decisions. So that's something that's going a lot of research into, and that's going to be exciting. Another thing that our current systems can't do is they can't really explain why they do what they do. They can say that there's a 99.7 chance of this being a broken bone, but it cannot tell you why it thinks that. And that has to do with some algorithmic limitations in the current systems we have. So that problem is called explainability, and there's a lot of research going on in explainability.
Mm.
Another thing that we can't really do is we can't unlearn things from these systems. So we haven't talked much about it, but these systems are all based on machine learning, where you show a lot of examples and then it understands something. Well, imagine if a system had learned what you looked like and I looked like, and then you came and said, "Well, I know my GDPR regulations, and I would like to be no longer recognized by this system. In fact, I would like all information about me to be removed from the system." Well, information about you is now totally entangled in what's called the weights of the system. So all the parameters that the system
Mm.
has learned, and we don't know how to pull that out. So that's called machine unlearning. That's
Mm.
quite exciting too. And
Right now, there's a case of ChatGPT. I don't know if you've seen it. It's all over my LinkedIn anyway.
yes,
About it basically breaks down when you ask it who David Mayer is.
yes. Now,
Is that
so
a problem from?
that's so we don't know because we don't know very much about how well we know roughly how ChatGPT works, but we don't know the inner workings of ChatGPT. So as far as I've seen, I haven't done a lot of research into this, but I have seen this too, and I don't think anybody really knows who David Mayer is and why that to have happened. So either it's something that has been programmed into the system on purpose because there is some David Mayer that it shouldn't be able to tell about, or it's one of these so-called emergent properties that has just happened by chance from this training, and that has to do with explainability. So if first of all, if OpenAI were interested in providing us this information, and if if we had explainability for these large systems available, then we would be able to query the system as to why it won't say David Mayer.
And
But we can't do that right now.
I'm actually also thinking that the fact that it doesn't want to talk about David Mayer does not mean that David Mayer has been forgotten by the system. It just means that it's programmed not to say anything about it. Of
Exactly the opposite. I mean, it is very aware of the name David Mayer because
course.
otherwise it couldn't react that way. Otherwise, it would just say, I like if I ask who is Andreas Møgelmose, it probably would just say I don't know, and it would say the same about David Mayer. So no, it's very aware if you can talk about awareness of
Yeah.
this name.
Yeah, and then that's the exact same implication you have with, uh, well, the right to be forgotten by the system. Your
Yes.
face, you have the right
Yes.
for the system to forget your face and etc. All this,
Yeah.
or the not even just your face, as you say, also just the way you walk, like
Yes.
the biological
Yeah.
being
Yeah.
that you
And then
are.
you can put a layer on top of the system saying, "Oh, the guy that walks like this, you're not allowed to recognize." But that doesn't erase your information from the system. That actually adds more
It
information about
amplifies
you
it.
to the system. Yes. So while it might have sort of the impact that you're looking for, which is you're not being recognized, it actually means that there's more data about you in the system. So if you are
Yeah.
interested in data about you being erased, we can't currently do that, except for taking you out of the training set and retraining everything, which is an insane amount of computational work.
Yeah, and then the next day someone else will say the same, and you'll have to do it all over again.
Exactly. So
Yeah, yeah.
that's a big issue.
In your own research, what are you looking at right now?
I'm very much interested in applied AI. So while I'm interested in innovating algorithmically, I'm more interested in taking existing algorithms and deploying them somewhere. So one project that I have that's sort of in the early phases right now is about how can we automate a particular type of screening that anesthesiologists do before patients are put into sleep before an operation. So that's one thing we're trying to automate. I'm also looking into how can we so a completely different thing, how can we get better colors on video? How can we better understand how humans see color? How can we use color information to segment video? So if you have some footage of a model on a catwalk, you would like to easily be able to cut that model out, despite changes in lighting
Mm,
along the way on that catwalk, and that is also not fully solved. So that's another like very practical thing I'm currently
mm,
looking into.
mm. It's very interesting. Andreas Møgelmose, thank you so much for joining us for this interview. And you'll actually stick around because in the next episode we'll dive into some of the more theoretical bits of computer vision and how it actually works and what implications that has. And it's going to be a very nerdy talk, I suppose, but it's going to be very fun. And to you there out there listening, thank you so much for sticking around. And if you like this episode, give it a like and give it a share, of course, with someone you think might be interested as well. And if you have any questions or topics that you want us to discuss here on the podcast, reach out to us on podcast at bigideasonly.com. That was podcast at bigideasonly.com. And I think that's it for now. Thank you so much for listening.